right. Your time is up for today's warm-up. Put your pencils down, pick up your colored pens. Today's warm-up is a review of ideas that we spent several weeks learning, mastering. So let's see how we did. I'm not going to the equity bars today because of the setup of the class. So I'm just looking for volunteers all day today. Number one, what did you get? We'll start with Marcus, and then we'll go to Isabella, and then we'll go to Yasmin.
X plus 5, x and x plus 7.
Mm-hmm.
X plus 7,
So, x plus 5 times x plus 7. Remember, this is a multiplication problem. Each expression is a factor. X plus 5 is a factor, x plus 7 is a factor, and we're multiplying them to get this expression. Very good. I got 3 people in the room who got it right. We'll see in a few minutes how everyone else did. Number 2, what'd you get? We'll start with Kaylee, and then Tyler, and then Adriana.
x minus 7 times
X plus 9 times x minus 7.
x minus 7 times x plus 9.
And they are all correct. You can take whole factors and rearrange them. So x plus 9 times x minus 7 is the same thing as x minus 7 times x plus 9. Very good. Number 3, what did you get? Start with David, and then Garion, and then back to Yasmin. Okay. Okay. It is 2 times x minus 4 squared. The 2 must be there, because if you don't have it there, then it doesn't come out to 2x squared minus 16x plus 32. Comes out to x squared minus 8x plus 16. So the 2 has to be there. Number 4, what did you get? Jesse, what'd you get? And then Isabel. Okay? So we have a disagreement. Chanel, what'd you get?
11 times 4x squared plus x.
So, you were close, but they had an x in common, so the x has to get factored out as well. So in this case, it would have to be 11x times 4x plus 1. Number 5, what did you get? So I said I'm not going to equity bars, but I will just start calling on random people just to make sure everyone is awake and alive and participating in class. We'll start with Paige and then back to Gary.
2x plus 5 times x plus 3. I got 2x plus 5 times x plus 3.
So we are in agreement that it's 2x plus 5 times x plus 3. And what about number 6? We'll start with Adriana, and then we'll finish out with Kate.
3x minus 7 times 3x plus 7. 3x minus 7 times 3x.
So you guys agree, and that is correct. Very good. So I gave you a big, giant hint. Had I not done that, not sure what the results would have been. Big, giant hint right here. Every question, every expression that I asked you to factor in this warm-up has something to do with one of these hints. So for example, number 6, 9x squared minus 49, that has a name. What is it called? What is it called? Jesse? That is a difference of 2 squares. You're supposed to know it instantly. That's a perfect square. That's a perfect square. That's a difference. Difference of 2 squares. One of these ends up being a perfect square trinomial. Which one ends up being a perfect square trinomial? Okay, Chopin? Number 3. Because when you take the 2 out, this turns into a perfect square trinomial, and that's why it factored like that. Could you factor it without knowing that? Absolutely. One of these, you needed to use the trick. Which one did you need to use the trick on? Marcus?
No. Well, I used the trick on 3.
Okay. On number 3?
Yeah.
Okay. Well, that's fine. And did it work out?
Yeah.
Well, how'd you get the 2 out there?
Oh, no, not the judge got X minus
But that's the problem, is then you didn't get the right answer. As said several times, that the 2 has to be there. That's not optional. So you had some success. Chanel?
4.
5, you really needed to use the trick because nothing else could be done. Remember, the trick is supposed to be your last resort. You're supposed to be able to recognize everything else. GCF is supposed to be first before anything else. So for example, sticking with number 3, 2, negative 16, 32. Instantly you recognize that they have a common factor of 2. Okay? Good. Does anyone have any comments or questions about today's warm-up? Any observations? Anything at all? So I know I might have thrown you off by all of a sudden pulling this back from a month ago. But here's the good news. Half today's lesson is done now. You'll find out in a moment why. Are there any observations or questions or comments before we proceed? Good. Today, we're going to explore how to solve quadratic functions by factoring. Believe it or not, I did not teach you how to factor things just because it's super fun. Thank you, Jesse, for playing along. That was supposed to be a joke. There was a purpose. You're going to learn the purpose today. We're going to do a little bit of a building process. You already know almost everything you need. Up until this moment, the only way you know of to find solutions to a quadratic is by looking at its graph. The only way you know to do it is if I give you a graph or you draw a graph, look for where the parabola crosses the x-axis, and you find your solution. So let me show you what I mean. So here I have a whole bunch of different quadratics. So hopefully you can see up here the actual quadratic. So I'm going to activate this one and show you what it looks like. Oh. So look at that. Someone tell me, what are the solutions to that quadratic? Got 1, 2, 3, 4, 5, 6 people who can see it. 7, 8 people. Amani? How do you know? That's right. This is the solution right here, right? Okay, let me try a different one. Very good. All right, let me not do this one. I'm sorry, give me a moment. Let's do this one. What are the solutions to this? Yasmin? Say it again. And so you can see the 2 right there and the 4 right there. All right, let's look at, let's do this one. Hold on, it's loading. So what are the solutions to this quadratic? Garion? -5. You can see it right there. Okay? So I'm cheating a little bit. I'm using a computer program to show you the graph, and then all we have to do is look at the graph and we know the solutions, correct? But last 2 lessons, we spent a huge amount of time learning how to actually draw this by hand. That process took a long time, and all we needed was where it crossed the x-axis. So, not surprisingly, at some point, either you should have asked yourself, or my students at some point asked me, Mr. Gallagher, is there an easier way to do this? It just happened this morning. We were halfway through graphing, and someone said, Mr. Gallagher, is there an easier way to do this? We had spent 15 minutes just on one graph. Well, guess what? Today's the day. Yeah, there's an easier way to do it. But the graph was really important, and you'll see why as we go through it. So, let me first lay the groundwork. The zero product property you have known probably since 4th grade, maybe 5th grade, maybe 3rd grade. You didn't know its name, but you knew how it worked. What it says is, if you have a multiplication problem, and the result is 0, then one of the multipliers must have been 0. Let's do a couple of examples really quickly. What am I talking about? Let's do this elementary school style. In elementary school, you saw something like this. Right? And your teacher put like a 9 there. This is how you learn division. Your teacher said, 3 times what number will give me a 9? And that's how you actually transitioned from multiplication to division. So now I'm saying 3 times what number equals 0? What does the question mark have to be? Go ahead as a chorus.
0.
It has to be 0. Thank you, Jesse, for playing along so well. What if I move the question mark over to this side? What if I do question mark times 3 equals 0? What does the question mark have to be?
0.
Thank you. What if I now change it to our more advanced form, as we know in Algebra 1 Honors? If I write 3x equals 0, what does x have to be?
0.
Thank you. So, what if I took it a step further and I said x times y equals 0? We don't know what x is and we don't know what y is. But now, not as a chorus, I'll take volunteers. We don't know what x is and we don't know what y is, but what do we know? What do we know, Adriana?
At least one of them is a 0.
I love the way you said that. At least one of them is a 0. You're the first person to ever say it that way in my class. It could be both of them are 0, but at least one of them must be a 0. This concept is the foundation for what allows us to do what we're going to do today. So what you're going to see today is use of the zero product property. It's a much more advanced use of it. So let's go ahead and jump in. Example 1, part A, copy down part A only. Do not copy this down yet. So, we are going to solve quadratics, and we're going to start out by solving them when they're already in factored form. Here's where we're going. We're going to come back to this in 1 second. This is what we're really going to do. We're going to solve these. But first, I need to teach you what you're allowed to do to solve part of this. So, I'm going to start by going just one step. Based on the zero product property, we have a factor times another factor, and the result is 0. Which means, as Adriana said, at least one of these must be a 0. So it's a little confusing, but basically what we can do is find out what number would go here to make that a 0. Find out what number would go here to make that a 0, and those two numbers would be the solutions. So to do that, what we actually do is take each factor by itself and set it equal to 0 and solve it. So we're going to take this factor, 7x minus 2, set it equal to 0, and solve it. Then we're going to take the other factor, 5x minus 15. We're going to set that equal to 0 and solve it. The two results will be the two solutions to the quadratic. Could someone remind us, what is this called? In that form. What's that called, Paige? That's a two-step equation. Remember from way, way back? At this point, you guys should be beyond Grandmaster Yoda level of two-step equations. You should be at some level that I haven't even got a number for. You should be master of the universe level. This should be instant for you. Some of you can do these mentally at this point. But just to make sure that everyone is following along, let's go ahead and solve these. You can go ahead and start on your own. I'm going to solve them up here. Add 2 to both sides. 7x equals 2. Divide by 7. X equals 2 sevenths. Solve the other one. Subtract 15. So we get two solutions. X equals 2 sevenths, and x will also equal -3. Those are the two locations where the graph crosses the x-axis. Those are the zeros of the function, those are the x-intercepts, and those are the solutions. So this is all because of the zero product property. It's kind of a shortcut, as I said, so that we don't have to graph this. I could graph it, but that would be an unpleasant experience. This is much more efficient. Remember, one of the aspects of algebra is to learn how to be more efficient and more effective. Does anyone have any questions on how we went through this? No questions? All right, so let's go to part B. X minus 9 squared equals 0. Well, it's hard to see all the factors. In part A, that's a factor and that's a factor. Because of this exponent hanging out here, it's hard to see all the factors. So we need to write it out in a more expanded form. Could someone help us write it out so that it's easy to see all the factors? Gary?
X minus 9 times x minus 9.
That's right. This really says x minus 9 times x minus 9 equals 0. So now we can see the two factors. So again, set this one equal to 0. Set this one equal to 0. Anyone notice anything? Kaylee, what do you notice? You said that beautifully. Yeah, we only need to do one of them. What's the answer? David? So x equals 9. So how many times does this one cross the x-axis? Yasmin? Okay, so let me pause here and go back to my other software and show you what you saw already. I did this on purpose. That's the same quadratic. So I showed you this before, and I'm showing you again because now all the pieces should be connecting together. Now you should be saying to yourself, okay, oh, I see it now. the graph crosses at 9, and I just took a shortcut to find that by just using this little trick of setting each factor equal to 0. Any comments or questions about that?
When things could be on the x-axis, wouldn't y have to equal 0?
Correct. Yep, absolutely. I had to think about it for a second, but yep, absolutely correct. And some of your classmates yesterday took a shortcut to find the solutions because on their table of values, anytime y was 0, they knew that that was going to be a solution. So that's a great approach that you just thought about. Okay, any other comments or questions? Okay, part C, I'm going to use for something, but we're not going to do it. So part C is here to illustrate just one idea. This is actually not quadratic, this is cubic. If we multiplied it out, it would have a highest exponent of 3. A cubic crosses the x-axis 3 times. 3 factors, you would have to solve each of them to find all 3 solutions. We're not going to do it. Again, I just put it here to illustrate that it's not just quadratics. It's all equations. In fact, if you go way back to the beginning of the year, when we talked about 2x plus 1 equals 10, you solve that, what you're finding is where the graph crosses the x-axis. That's what you're doing. So we're still doing the same thing we've always done. It's just now magnified in complexity because of the nature of quadratics or anything beyond that. Any comments, questions before we move ahead? Good, now you're on your own. Checkpoint number 1. Solve each of these. You've got 3 of them. You got 3 minutes. If you finish before the bell rings, then compare your answers to your teammates to see how you did. Based on how quickly some of you finished, I'm hoping for great success. Let's see how we did. Part A, what did you get? Start with Kaylee, Amani, and then Kaylee and Amani.
7 and
X is 7 or negative 2. You can write 7 or negative 2. You can put a semicolon. You can put the word and. It's all pretty. Or and are not the same thing, but for the purposes of this, it's fine. Part B, what did you get? We'll start with Tyler and then Yasmin.
I got x equals 2, semicolon, 0.
X equals 2.
Okay. X equals 2 or 0 or 2 and 0. What about part C? We got Gary and then Isabella.
X equals 10.
Very good. Anyone have any comments, questions, concerns? Give me a thumbs up if you got them all right. Now I know why there's no comments, questions, or concerns. Good. Put your thumbs down. Now we can move forward to the real work. So I put the first 6 questions in factored form already so that we could focus on using the zero product property. That was done intentionally. But now I'm going to go back. You will not be, from this point forward, given quadratics in factored form, maybe a couple more times, like a couple on the homework, but beyond that, you're not going to get them in factored form. You have to put them into factored form. So, let's go ahead and get started. Part A. X squared plus 4x equals 21. We could graph it and get the solutions. But that's a very time-consuming and sometimes inaccurate process. We can be much more efficient. To solve this, though, using by factoring, we need to have this in standard form. I have standard form written on my board right here. So we need this to look like this, although instead of the y, we're going to have a 0. We want it to look like that, or it can be flip-flopped the other way. We also want to try and keep things positive. I'm not saying keep things positive as far as the attitude. I'm thinking positive numbers. So we could move the x squared over here, and we could move the 4x over here. But that would make those negative. So instead, let's take the 21 and move it to the left. So we will end up, by subtracting 21 from both sides, we end up with x squared plus 4x minus 21 equals 0. As long as you have a 0 on one side, you can now solve it. That's part of the zero product property. Now we need to factor it, and this is why we did today's warm-up, so that you would be prepared for this part. You should now be going through your checklist of factoring. GCF, difference of two squares, perfect square trinomial, unwrap the foil, do the trick. What applies in this case? Go through the checklist. Go ahead, Paige. Yeah. There's no greatest common factor. It's not a difference of two squares. It's not a perfect square trinomial. But this is a 1. When that's a 1, that means it's probably going to be able to unwrap the foil. So that's what you do. So go ahead and get your parentheses set up. Make sure you put equals 0. And go ahead, unwrap the foil. Should take you 30 seconds. No calculators even needed. Give me a thumbs up if you got the two factors. Good, good. That whole team, almost this whole team, almost. Good. Put your thumbs down. Okay, Chopin, what are the two factors?
X plus 7
Times x minus 4.
No.
X minus 3, sorry. So that multiplies to negative 21 and adds to 4. So that you learned a month ago. Now we're applying it to here, solving. Now you know what to do from here forward. What do we do at this point? Go ahead, Yasmin. Very good. Set each factor equal to 0. So we set x plus 7 equal to 0, solve that, and set x minus 3 equal to 0, and solve that. Most of you should be able to do this mentally. If you can't, that's okay. But you should move towards being able to do it mentally. And find the two solutions. What are they? What are the two solutions? Jesse?
I got 3 and 4, -7.
So we get -7 and +3. Those are the two solutions to the quadratic. And I can prove that we got it right. Let me get rid of this. You guys didn't even notice. But you can't see the whole quadratic because it's so big. But you can see where it crosses the x-axis. The vertex is way down there. So it crosses the x-axis here. And it crosses right there. This is the connection. This is the key part. This is why we did the graphing, so that you could make the connections between all of these different ideas. So now you can see what the significance is of being able to do this. Any questions about that? Okay, part B. X squared minus 6x plus 8 equals 0. Solve this by factoring. First thing, we need it in standard form. What should we do first? What should we do first, Alex? Beautiful. Nothing. It's already in standard form, which means we are now running through our factoring checklist. GCF, difference of two squares, perfect square trinomial, unwrap the foil, do the trick. What applies in this case? Okay, Jobet? Yeah, unwrap the foil. Go ahead. Should take you 20 seconds. Maybe 5 seconds. 2 seconds? You're done already?
Yeah.
Oh, okay. You were way ahead of me?
So far.
Give me a thumbs up if you've got the factors. Okay, Isabella, what are they? X minus 2 times x minus 4. Very good. That foils to x squared minus 6x plus 8. Excellent. And as Yasmin explained or reiterated from earlier, now we know what to do with that. Set each factor equal to 0. X minus 2 equals 0. X minus 4 equals 0. And solve both of those. And we get what solutions? Dave? Get 2 and 4. If I go back to the graph, deactivate this one and activate this one. That's the same quadratic, and look at the graph.
It's amazing.
Any questions about that?
Oh, I see. It's hurting me so bad.
All right. So now, those two were on the, I guess, lighter side, a little bit easier. So let's up the level of complexity just a little bit. Procedure-wise, we're not doing anything different. We just have to pay attention to details and make sure we're following that factoring checklist that we were supposed to have mastered. Again, first thing is we got to get it in standard form, but we also want to try and get things positive if possible. So what should we do in part C to keep all those things going? Okay.
Add 2x to the
Very good. Add 2x squared to both sides so that this jumps over there and becomes positive. And so we'll end up with 0 equals excellent. Now, run through the checklist. What do you got, Gary? That's right. Very important to see. Very important. It's got a greatest common factor of 2. So we rewrite this as 0 equals 2 times whatever's left over. X squared plus 10x plus 25. It didn't come up during today's warm-up in this class, but it came up in both of my other classes that 2 of the questions students did the greatest common factor, but that they didn't finish. They just stopped. It's not just a one-step thing. The checklist that I keep talking about, the factoring checklist, you have to go through all of them to make sure that you are done. You don't stop until you can't factor anymore. And so now you should be looking at this and saying to yourself, okay, what on the checklist applies to that? Give me a thumbs up when you think you've got it. 1, 2, 3, 4, 5, 6. Okay, Adriana, what do you see? Unwrap the foil. Alex, what did you see? Unwrap the foil. Anybody see anything different? Okay, Chopin? Paige, what did you see? So you can do either one. But that's a perfect square trinomial, and I can factor it. I'm done already. If you want to unwrap the foil, it doesn't take very long. It's going to take you 20 seconds, maybe less. So it's not really that big a deal. But just so you know, I'm already done. And so are my students who saw that it was a perfect square trinomial. This is a perfect square. That's a perfect square. And this is twice the square root of that times that. That's the PST test. So no matter what, it's going to factor to the same thing. If you do the shortcut, if you do perfect square trinomial, you'll get this. If you unwrap the foil, you'll get this. Either way, it's the same thing. Either way, it's the same. But the whole point of all of this was to get to this point. Now we set each factor equal to 0. This is a factor, and so is this. So we set 2 equal to 0, solve that. Set x plus 5 equal to 0, solve that. Set x plus 5 to equal to 0 again, and solve that. But then Kaylee would say, well, Mr. Gout, that's just silly, because why do it twice? So go ahead and solve. 2 equals 0 is not something you can solve, so we disregard that. So just solve x plus 5 equals 0. X equals what? X equals what? Cheyenne? -5. Any questions about how we went through this? Let's prove it one last time.
Who would have seen this?
Any questions about that? Any concerns? Any observations of any kind? All right, checkpoint number 2. You are on your own now to solve both of these by factoring. And you've got 5 minutes on the clock.
This is hard.
All right. Colored pens up. Let's see how we did. Part A, what'd you get? The solutions, please. I got one person who got it. 2, 3 people who got it. Okay, Paige, Yasmin, and Gary. Okay. X is negative 5/3. And part B, what do you get? Same group, okay. Karen, then Yasmin, and then Paige.
X is 1 and also 1/3.
I understood. So let's start with part B. What did you need to do for part B? What you need to do, Yasmin? The trick. So part B, you should have run through your checklist and said, okay, I can't do anything except the trick. But let's go to part A. This is where I am going to make some of my students feel silly for not knowing something that would be very beneficial to know. After you rewrite the equation into standard form, what do you end up with? What do you end up with? Cheyenne? I'm sorry? Yeah, you do, but could you tell me what it is? And Cheyenne, that was very astute. You said it turns into what? Yeah, that's a perfect square trinomial. If you try to use the trick, you can do it. But you're going to spend a lot of time trying to figure out two numbers that multiply to whatever 9 times 225 and add to 30. You're going to spend a huge amount of time doing that. So now here's a case where knowing the shortcut greatly improves your efficiency versus not knowing. This is a perfect square. That's a perfect square. The PST test. Square root of this times the square root of this times 2 should equal that middle number. Now factor it. A perfect square trinomial will always factor to this. The square of a binomial. Square root of this, square root of that, whatever is there goes right there. That's factoring from a month ago. Now, solve. Set each factor equal to 0, so you set 3x plus 5 equal to 0. Solve that and you get x is negative 5/3. Any questions about that? Give me a thumbs up if you recognize that that was a perfect square trinomial. Good. Put your thumbs down. Excellent. Any comments or questions? So now let's apply this to something real. So the vertical motion model is an important tool for doing research out in the world. So that's why we keep coming back to it. You do not need to copy the text of the question. You need to read the question to yourself. And I am going to change one thing. I don't like the way this is. So you've read the scenario. We're talking about a rocket that's getting launched from 160 feet up in the air, a cliff. We don't have a huge number of cliffs in Florida, but maybe by the ocean we do. But all over the country, there's plenty of them. So a rocket is being launched, and its vertical velocity is 48 feet per second. 48 feet per second. That's its vertical velocity. That's in the function right there. So we're going to solve this. We already know that because I wouldn't have it in this lesson if we weren't. But we need to understand what's happening. So we need to review what the letters mean. To proceed, you need to understand what H is, and you need to understand what T represents. You're told in the text of the question, but I want to clarify one thing. H is the ending height, where the object ends up. That's H. S is the starting height, and that's right here. Starting height, 160 feet in the air. Ending height. In the past, you've seen a basketball player. I've talked about throwing a ball and another person catching it. The ending height is different depending on the scenario. In this scenario, I am asking you, how long will it take for the rocket to reach the ground? How does that part of the question factor into what we're doing? Kaylee, and then we'll come over to Gary. Okay, what were you going to say? H would be 0, and you said the ground would be 0. And you're both right. That's exactly it. For the purposes of doing research and studying, the ground would be 0. Now, we're actually on the second floor of a building. This is the ground of this classroom. If we were doing a scientific experiment in this room, then we could say that that's 0. But if we were talking about something more complex like a rocket launch, then 0 would be the actual Earth, not this floor. So again, it's based on circumstances. So Kaylee was right, and so is Gary. H is going to be 0 because the ground, the Earth, is 0, and I'm asking how long will it take for the rocket to hit that point? So we need to take this and modify it with one little detail. We need to change this. So now we will end up with 0 equals negative 16t squared plus 48t plus 160. And now we want to solve it. We could graph it, and that would be an absolute nightmare. Because the first thing you need is the vertex, and the vertex would be the opposite of b over 2a. We're already involved with fractions, and then we'd have to plug it in and get a nice big number, and it would be a nightmare to graph. It would take a while. But we have just learned today a more efficient approach. So run through your factoring checklist. What's the first thing on the checklist, Adrian? And you already know it? What is it?
8.
8.
Or 16.
Or 16? Which one would be better to use? Good, but there's also something else. What other detail do we want to take care of right at the beginning? Paige? We want to get rid of that negative. So we're not going to factor out a 16, we're going to factor out a negative 16. So we'll rewrite this once again. 0 equals negative 16 times whatever's left over. So go ahead, you write what's left over. Watch how easy this becomes. Could someone help fill in the rest of what's left? Go ahead, Cheyenne. T squared minus 3t minus 10. And so now we went from this really complex looking equation to something that should not really feel too intimidating. This quadratic right here. And we are not done factoring. Remember, you keep factoring until you cannot factor anymore. So we have one factor, it's negative 16. But now run through your checklist again. What can we do with t squared minus 3t minus 10? Yasmin? Yeah, we can unwrap the foil. In fact, it should be done already. We unwrap the foil. So go ahead. Could someone tell me what it is? You got 1, 2, 3, 4. Go ahead, Chanel. T minus 5 times t plus 2. Cheyenne, you agree with that? You got the same thing? Good. So again, I want to point out how this started out so complex, and then just because of our skills with factoring, we're able to turn it into something that's very manageable. So now, Yasmin, what's the final thing we need to do that you told us about earlier? At the end that we learned today? I know, I put you on the spot, made you uncomfortable, I'm sorry. Go ahead. That's right, and you actually technically put negative 16, you set that equal to 0 and solve it, but because that's not something you can solve, you disregard it. And then she's right, we do t minus 5 equals 0, and then t plus 2 equals 0. And solve both of those. Go ahead. No, what's your question? Well, you already answered my next 2 questions, so thank you. That was great. So my first question was going to be, what are the solutions? And my second question was going to be, what's the actual solution? So she already answered one of them. This comes out to t equals 5. This comes out to t equals negative 2. Give me a thumbs up if you're already at the point where you're doing that mentally. If you're doing it from here to here, you're doing it mentally? Good. Put your thumbs down. That's awesome. So, Cheyenne, which is the real answer? That's right. So, the answer to the question is, how long will it take? Answer the question. It's going to take 5 seconds. It's going to take 5 seconds. Anyone have any concerns about that? Yeah.
If the variable has a coefficient of 1, the x just equals the opposite of the next number.
You're talking about the factor?
Yeah.
Yeah. In fact, I actually think of it like this. The whole point of the zero product property is this. You're trying to find what number will make that expression equal to 0. So what number would have to go here to turn that into a 0? That's to be a 5. 5 minus 5 is 0. What number would have to go there to turn this whole expression into a 0? A negative 2. So that's what Paige is pointing out, is that the answer is just going to be the opposite of the number that's right there. That's right. Very good. And we disregarded this answer. That does not apply. Any other comments, questions about the vertical motion model and applying what we've learned to something real? Good. Let's see how you do on your own. So explore this scenario on your own. And after you finish, wait for your teammates to finish and then compare your answers with them. Got 4 minutes on the clock. And of course, if you need any guidance or help, please let me know. Oh, okay. Oh. see how we did. Take volunteers. So we'll start with David, Yasmin, Adriana, and then Paige. David, what'd you get? I'm sorry, I can't hear you at all. Okay. 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 Half a second. Okay, so we have kind of some different possibilities. So let's come out to 1 second. Although, as I'm looking around your work and thinking about this, maybe something's off. Let's explore for a moment. Maybe there's a mistake somewhere. I trust my students when I feel like a lot of students got different answers and maybe I made a mistake. So let's explore, make sure I did it right. So we know that we're looking for a person who's diving off of some platform and he's way above, so he's 8 feet above. He's going to dive down. We're looking for when does the diver reach the water, after how much time. So we know, as Garion said earlier and Kaylee said earlier, the water in this case is the ground, or 0. So that's going to become a 0. So you should have started out setting this up. And then where'd you go from there? Because I'm honestly not feeling super confident about myself right now. Go ahead, Keisha. -8. Okay. So that was my instinct as well, was to get, I saw that they had a common factor of 8, and we definitely want to get rid of that negative. So we factor out a -8. And what were you left with, Keisha?
2t²
Okay. So this looks like it should be easy, but maybe I did it too quickly, or maybe I made a mistake. So let's explore that. That can be, hopefully can be factored. I thought I did. So we already did GCF. It's not a difference of 2 squares. It's not a perfect square trinomial. That's not a perfect square. Can't be done with unwrap the foil because that's not a 1. So that leaves us with the trick. So we do A times C. We get -2. And we want 2 numbers that multiply to that and add to that. So we get -2 and 1. Is that right? I'm being serious. I'm looking for your help. Is that what you guys did? Okay. And then we put both of those over A. So A is 2. Put them both over A. And so this simplifies to -1 over 1. And this is already simplified 1 over 2. The denominator is the coefficient. The numerator is the constant. So this will turn into 0 equals -8 times x minus 1 times 2x plus 1. Oh, I put an x instead of a t. Go back. Sorry about that. So now we solve each of those factors. -8 equals 0, can't factor it. T minus 1 equals 0. That's going to be t equals 1. And then we need to do 2t plus 1 equals 0. And that will come out to t equals -1/2. So one of those answers will not work for a reason that we've heard already. Which one won't work and what's the reason? Tyler could tell us. Because he told us before. At some point. You told us a different day when we came across this. That's okay, I know I kind of shocked you back into reality. So Cheyenne will tell us from today. Can't have negative time. That does not apply. So t must be 1 second. Any comments or questions about any of this? Any concerns of any kind? All right. Your homework is on page 451, numbers 1 through 23. And on page 452, you're doing number 1. That's a total of 24 questions. Algebra Nation. We're moving on to sections 3 and 4. By the end of next week, I will put in the grades all the way up to section 4.